Hi, how are you? Good? Yeah, great. Boa tarde. That's the only Portuguese that you will get from me today. So my name is Maximiliano. I know it's a long name, so I can go by Max or Maxi, however you want to call that. This is going to be breaking the limits of PWAs, progressive web apps. So before starting, how many of you know what a PWA is? Let's see. Okay, so quite a few, but not 100%. So I will start really quickly talking about that so we understand exactly what they are and what are we going to talk about. First, about myself, really quickly. So I'm a web and mobile developer. So I have been doing web for 26 years at this point, and mobile apps for more than 20 years. So that's before the iPhone, before the Android. Remember Nokia, Blackberries, all the stuff. So I've been doing all the stuff. And after that, also iPhone, Android development. And I'm from Argentina. I'm from Buenos Aires. Okay, that's why, yeah, Portuñol. That's all I can do on Portuguese. Firt.dev, my website, at Firt on Twitter. That's my account. So recently, also in the topic of PWA, I have written or authored this content. It's a free online, let's say, course slash ebook, interactive ebook with the support of the Google Chrome team. So it's actually on web.dev, web.dev/learn/PWA. So if you want to learn more about everything I'm going to tell you today, you can go there. It's free. So also you will find content that I author in many platforms. Okay, so if you have experience with these platforms or you have access to these libraries, okay, you will find content. Anyway, about this talk. So we are going to talk about PWAs. So a progressive web app is just a website that you can quickly install or add to your home screen. And when you do that, thanks to service workers and web app manifest, it will look like an app. So this is Android, okay, what you're seeing there, but also you will see something very similar on iOS. So you can go to an iPhone or iPad and you can install that website as an app. But it's not just on mobile. Okay, a progressive web app today is also compatible with desktop. So actually, you can do the same on desktop. So if you go to, for example, Scoosh, that's a PWA. You can install that on Windows 7, 8, 10, 11, Mac OS, Linux, and Chromebooks. And when you install the website, now it's an app. Okay, it appears like any other app in that operating system. So that's actually a PWA. But about this talk, in this talk, what I'm going to show you is how to push the limits a little bit thanks to new JavaScript APIs that we have available today. Okay, so have in mind, like a warning part, that not everything that we're going to see is available on every platform. You know, if you're a web developer, you also know how this works, right? So, but I will tell you exactly what works in iOS, what works on desktop, and that what actually works on Android, okay? So the first problem that I'm going to show you, and it's a problem that you may have when you go to a customer, you go to a client, or even in your own company, you want to actually push PWAs. So you go to your manager and say, hey, we want to do a PWA. The first typical issue that you encounter is that no one knows about this apart from web developers, and it's difficult to install or for users to understand how to install this. So who is going to go to the menu and select add to the home screen? I mean, in terms of users, they don't do that, right? So that's a problem. So I'm going to show you, let's say, new techniques or APIs that we have available today that can help into this problem. So we're going to break the limits here using two ideas. One is called promotional fields, and the other one is before install prompt. The first one has to do with the web app manifest. The web app manifest is a JSON file that we set with our website. Before install prompt is actually a JavaScript API. So promotional fields in the manifest looks like this. So in the manifest, you add metadata or you set metadata for your app. Today, you can also add a description to your app. It's just a long text describing how good is your app. And also you can provide screenshots. The screenshots is an array of data, okay? So you take screenshots, desktop screenshots, mobile screenshots, and you put those screenshots there, okay? Remember this. At this point, you're thinking, okay, why is this so important? Okay, I will show you what's the difference. So before install prompt is a JavaScript event that you can listen to on the window object, like the code you have there. So you listen to before install prompt and you receive an event as usual, that E object that we have there. And what we're going to do is we're going to save that event for later. That's kind of the token, the power to trigger the native installation dialog. So instead of expecting the user to install the app manually from the menu, we can actually receive that event. And that's kind of the power to ask the installation when we want to. Then, for example, you can have your own install button in your user interface, wherever you want. And when the user clicks on that button, you can prompt the installation dialog. So you can invite the user with your own words, in your own terms, in the moment that you feel that the user will say, oh yeah, it's a good idea to install the app. And then you trigger that. If you mix these two technologies, so before install prompt and the promotional fields, today, for example, on Android devices, tablets and phones, you will get a much better installation experience that will look like this. You have an install button there, you click there, and that's the dialog you see. First, it's a nice dialog with screenshots, and it has an install button. It doesn't say add to the home screen anymore. It says install, which for the user is actually more interesting. We know what install means, right? No, add to the home screen, I don't know what that is, okay? So it actually makes a much better experience for installation, and it will increase conversion. So more users will actually convert and install your app. So that's the first problem that I have for you. The second problem that I want to break the limits and do a better experience has to do with desktop. So I mentioned that today you can install a PWA, a progressive web app on desktop, macOS, Windows, Linux, and Chromebooks as well. The problem that we have is that now we are an app. It's not a browser tab anymore. So the thing is that we have already lost the ability as web developers to manage the window. So we need to remember some APIs from the 90s. How many of you were web developers during the 90s? I'm the only one, right? So I remember those APIs, and I will show you those APIs. So there is also new APIs, not only APIs from the 90s, multi-screen Windows placement API, and Windows controls overlay. So first, from the 90s, that's Netscape. Have you ever browsed the web with that one? Yeah, we have one hand. Come on, yeah, two hands. Great. So Netscape, or our old friend Internet Explorer, okay? When we were browsing here, we didn't have tabs, so tab browsing. So basically, every website was just a browser window. And because you were owning the window, JavaScript let us, at that time, move the window or resize the window, okay? So actually it was common to get into a website, and that website was actually shrinking the window or increasing the size of the window, and so on. When browsers started to using tabs, now one tab cannot touch the window because, hey, it's not just my tab, there are other tabs here. So that's why browsers stopped using that API. Now we can go back to those APIs from the 90s, and they're still here, and they're useful for when you're doing PWAs for desktop. It's just window move to, window size, resize to, and window open. Okay, so when you use these APIs now, when you are creating progressive web apps, and those progressive web apps are installed by the user on desktop operating system, you get the nice experience. So in this case, I'm in the browser, so I'm going to install the app. After the app is installed, it has its own window. And now from JavaScript, you can open new windows. You can resize those windows just with JavaScript. You can move those windows, okay, and so on. Also, on some operating systems, the user can open new windows from the menu. So for example, you will see now, I think that I will go now to the menu at the top. In the File menu, you can create new windows. And then you can have many windows of your own JavaScript app. Have in mind, from a developer's point of view, these are just different tabs. So you can use cross-messaging APIs to send messages between them, or you can use share workers to share actually code or processes between those windows. Okay, so that's how we break the limits. So the first step into breaking the limits of what a web can do these days. Then we have a new API. It's called Multi-Screen Windows Placement API that is already shipped on Chromium-based browsers. But to be honest, when we're talking about PWAs and desktop installation, only Chromium-based browsers are supporting this. So if you are using Firefox or Safari on desktop, you cannot install PWAs. So it's Chromium-based. So 100% of the browsers compatible with desktop PWAs are supporting this API. With this API, you can actually make a query about the current screen situation, such as, do we have additional screens? I have a primary screen right now, but I also have through HDMI a secondary screen. That's the one you're seeing there. Well, with JavaScript, I can actually query about that. I can know the details, the names of the screens, and I can actually position windows in specific screens. And if I remove the HDMI, I'm not going to do that, but if I remove the HDMI, there is an event, screens change, that you can listen to know that something has changed in the environment. So you can reposition, rearrange the windows based on your settings or whatever you want to do. Okay, this is actually useful now when we are working with multiple monitors, or when you're sharing the screen, you're making apps like Zoom or Meet, where you share your screen with JavaScript, with plain JavaScript. Well, you can use these APIs. Another new API that actually is coming in stable next month, I think, in Chromium, in Chrome 102. So it's probably within the next 1 or 2 months. It's Windows Controls Overlay. With this, you will be able to add in something in the manifest. So in the web manifest, the same JSON file that we mentioned before, you can say that you want to use Windows Controls Overlay. And when you do that, this is desktop only, so it's going to be ignored on Android or on iOS. So what we are going to get is something like this. You will be able to render content in the title bar. So if you pay attention there in the title bar has HTML. That's actually HTML, CSS, and JavaScript in the title bar. So you can extend your content there. There are a couple of CSS environment variables as well to make the design right. Okay, and you can use progressive enhancement, so JavaScript APIs, to know if you are in that mode or not. Okay, and also you can use media queries as well. Okay, so this is actually coming pretty soon. So if you're making PWAs, it's maybe good to start using that if you feel like it will improve the user experience of your app. Okay, make sense? Good. So number 3, this is breaking the limits number 3, OS integration. So one of the problems that we have as web developers compared with native app developers, but I'm kind of both, by the way. But anyway, I'm now in the position of a web developer. So as a web developer, our apps, our websites, I mean, if you're using React or Vue.js or Svelte to create apps, your apps are not well integrated with the OS. So they live in the browser, and the users need to go and type the URL or open the icon, like double clicking in the icon or finding the icon in the phone to actually use in our app. And today, okay, to solve the problem that being more integrated with the OS, we have more solutions that are actually available today or in the near tomorrow. File handling, protocol handler, web share, and web share target. So let me talk about these APIs. File handling. This is also another capability that we can set in the web app manifest. In the manifest, we can say that now our app can read some special type of files. For example, I can say that I can read CSVs, comma separated values, or PDFs, or PNGs. So I'm a PNG viewer. Or it can be your own custom file type. It doesn't matter, right? So when the user installs that PWA in the OS will register your app as a target for those files. So then when the user just double clicks on a file of that type, your PWA will appear as a possible target, okay, as a native app. I mean, when you double click in a .doc file, typically Word appears if you have Microsoft Word installed. Well, now you can also be a Word viewer. You just need to use the MIME type of the Word file. And then when the user double clicks on the Word file on Windows or on Android, your app can actually appear and say, yeah, I can read Word files. Okay, so that's fine handling. This is already shipped, by the way. Some things are still unstable, so they're still coming, but in the next few months. After you set that from JavaScript, you will actually, there is a queue known as launch queue that will be there waiting for you to request. You request the queue, you consume the queue, and the queue will contain there the files, the file or files that the user has actually used to open your app. And then using the file API, you can open the contents and do whatever you want. You already have permission to open that file automatically. Protocol handler is something similar, but instead of files, for protocols. So for example, you can listen for the all mail to. Remember mail to? Mail to colon, when you want to make a link that opens the mail application. Well, your PWA can also be a target if you're doing a webmail, can be a target for MailChimp. Or you can create even your own custom protocol. For example, web conference. They must be prefixed with Web Plus. That's the only requirement, to create your own custom protocol. So then, when your user installs the PWA, it can also respond to those links, web conference. So then anywhere in a website or in an email, you can say, if you have installed the app, click here. And that will open directly the PWA instead of a website. And then you can get in JavaScript the arguments, because it will open that URL. So it will open your PWA window with loading that URL. Okay, does it make sense? And you receive the argument in that percentage S, actually as a string. Web share. This is probably an API that you know. With web share, actually you can connect your content, the content on your web app, with the rest of the operating system. So you can share content. Right now, the API supports text, URLs, and files. So from your content, you can share to the rest of the operating system files. So for example, this is on iPhone. When you click on that share button, it opens the share native menu on iOS. And you can share data, files with Twitter, Instagram, TikTok, Word, whatever app you have that can be a target of that share. It doesn't need to be a PWA, it can be anything. This is working everywhere. Okay? It's working on iOS, Android, and desktop. And there is a final version of this tip that is web share target. That this is not on iOS, so it's available on desktop, on Android, but not on iOS. Web share target lets your PWA be a target of a share operation from another PWA or from another native app. So then your app will appear in the share menu of the OS. In this case, you also need to go back to the manifest and you need to declare that your app will we receive shares. And then you can specify if you want to use get or post. So you can actually receive a post request to your service worker that will get the data, and you can map your arguments. So you can call, so in the standard, it's called text, for example, when you receive the text, but you can map that to a contents query string variable that you name contents, okay? And you will get then your action, a navigation to your action with all the data as query string arguments. Okay, makes sense? Another problem, augmented reality. So today doing AR, augmented reality for the web, is kind of tricky. But today we have two ways to break the limits. One way is called Safari Quick Look, and the other one is called Model Viewer. With Safari Quick Look, you can actually put a link like this, an anchor, normal link, but it has a rel equals to AR, augmented reality. And then you link to a USDC file. This is actually a 3D model that it's an open format pushed by Apple, but it's open anyway. And within the link, you put an IMG tag that is actually the thumbnail. So what you see before actually clicking on the image. And just with this, you will have an augmented reality experience by default. You don't need to write any JavaScript. Google, on the other side, created something similar as a web component. It's called Model Viewer. In this case, you need to import the web component from CDN, and then you use the Model Viewer tag that has more arguments than the previous one. When you use these tags, what you get is an experience like this. This is this morning at my hotel room. So I can actually put something on the table like that, okay? And I'm pointing with my phone, and then I'm moving my phone around. This is pure web, so there's not native apps. We don't have any native app here, okay? So you can see that, and with my finger, I can take that object and move it into my reality, okay? And this is, again, this is just Safari, so now you will see that I will get out of this experience. It's a full screen experience, and I'm in Safari, so I'm in the browser, okay? So it's just pretty simple how to break the limits of the browser. Keyboard. So I'm not sure how many of you have been designing apps for mobile devices, okay? But typically the keyboard is an issue. Why? Because the keyboard is using a part of our screen, right? Let's say a pretty fair large part of the screen. What happens when with your content? Typically, it falls behind the keyboard, and then the user cannot click the button. Or there are issues, right? Because we have accessibility issues and usability issues because the keyboard is hiding contents. Okay. Well, now we have a solution to that problem. It's called the Virtual Keyboard API. Thanks to JavaScript and CSS environment variables, we can actually work with the keyboard that was actually impossible before. Let me show you some examples. You have the navigator.virtual keyboard object, where you can ask, for example, if you want to overlay or not the content. You can show and hide the keyboard, okay? And also you can listen for a new event. Its geometry changed. It's the geometry of the keyboard, okay? That's going to be fired every time the keyboard appears and disappears, and also when the keyboard changes. I mean, this is not common, but I'm not sure if you try this, but you can install more than one keyboard in your phone. And you can swap between keyboards. And each keyboard can have a different size. Not every key, it's not a standard size. Every keyboard is using the size it wants, okay? Makes sense? So geometry change will actually will fire an event, and you can listen for that event and do something with it, okay? So I have an example here on CSS as well. You have some environment variables, so you can know exactly when the keyboard starts and ends with CSS. So you can apply this on margins, and then you can put some kind of part of your UI on top of the keyboard always, okay? So to see this in action in a video, here you have like a chat system. So when you click on the input field, the keyboard appears and everything moves up. And also you will see here that there are some geometry change fires. Every time it appears and disappears, geometry change is fired with the information about the keyboard, okay? So I think that we have a question, but I think that we are leaving the question for the end. So if you can remember that question, keep that in your tongue, and we will answer that later. Okay? So that's a keyboard, okay? So voice. The web is typically text-based, okay? So text, we have text, we read text, we ask the user to type text. But today we can always, or we can also work with the voice. And for that, we have two APIs that are actually not new, but today they are now available everywhere. That this is new. Speech recognition and web synthesis. So with the speech recognition, with a very simple API, you can start listening for the microphone, but instead of receiving the raw audio, you will get the transcript text recognized by your phone or your desktop. It works on desktop as well. Okay, so you can make your own Siri, your own Alexa in your website with just JavaScript. You don't need to pay any fees to any voice provider, SDK. No, it is built in your browser. And you can decide the language that you want to use. So if I want to read for Brazilian Portuguese, you can do that. Okay. And here I have an example. I'm not sure if the audio will actually appear, but anyway, because it's the audio, I think it's going through the HDMI. But anyway, I'm speaking in English, thank you for the conference, and it's actually taking that. I'm changing the language to Portuguese, and yeah, my Portuguese is not good, but even with that Portuguese, it worked when I was saying, muito obrigado para conferencia, pela conferencia, okay? So actually it works. So it recognizes and it works pretty fast. On some browsers, it needs to be connected, so it works online only. On some others, it also works offline. So actually, it depends on the platform, okay, and the platform on how they are implementing this. And this is speech recognition, but we also have the other way. We have web synthesis that lets you speak through your website. Okay, so in this case, it's pretty simple. You create a message. There are many properties and settings that you can change here, like the pitch, the rate, the volume, the language. You can also change sometimes the voice. So on some operating system, you have different voices installed. And then you can let the user, or you can from JavaScript pick the voice you want to use, like a female voice, a male voice. Okay? And then you say speak. That's how it works. Okay. Again, I'm not sure. We can try. Okay? You're going to listen to something here, but anyway.
Hello, this is a great conference.
That's English. Okay. So that's how it works. You just put something there, and you can change the voice, change the language, and this is pure JavaScript. Okay, so you can actually make a voice-compatible web app if you want today. Object recognition. So far we've seen voice recognition, but what about object recognition? I'm talking about seeing the reality that we have around us and recognizing objects. Today we have an API that is still not completely stable. So some parts of the API are shipped and some parts are under an experimental flag. Okay, so if you want to try them, you need to enable the flag. It's shape detection. With shape detection, you can, for example, detect the barcode. This works on Chromium-based browsers, such as Android, Chrome on Android, Edge on Android, Brave on Android. So you create a new barcode detector and you ask for detect. You pass an image. The image can be a PNG, or it can be an image that you are taking from the camera. If you have permission, users permission to access the camera, you can get the raw image from there and run this through dynamically through the images that you're taking from the camera. Okay, and you can detect QR codes, normal 2D barcodes. So there is a big list of formats supported by this. So QR codes and barcodes are the most useful ones. Then we have face detector. This is under an experimental flag. With face, it can recognize a face or more than one face. So if I take a picture of you, it will detect the faces. It will give me the coordinates of the face, the center of the face, and also where the eyes are, where the nose is, where the mouth is. So you receive the coordinates, X and Y, and you can put things on top. You can draw a mustache or something like that over the face that was detected. And finally, you have also text detector. That is actually using OCR. So it's recognizing text with the camera. And I have a video on that one because I think it was more interesting. So you open the camera, just plain JavaScript. I take a picture on that old Pan Am schedule to London, flights schedule, read text, and read the text. It gives me text. And this is just a JavaScript API. I'm not using any SDK or cloud-based framework to do that. And the last one that I have for you today is media playing. When you're playing media today, video or audio, you want to integrate with the watch, if you have an Apple TV, with the phone lock screen. So today you have media session. With media session, you can actually set the metadata for the current playing. Like what are you playing, the name of the singer, the artist, the album. You can pass artwork, images. And if you have an iPhone with an Apple Watch, you will see that image there, even if it's a PWA. And you can set handlers. So from the watch, I can play, stop, seek, move forward, and you receive in JavaScript different event handlers for all of this. Okay, so you can actually integrate this with Android, with Windows. Okay, these are just examples of integrations, and also iOS and the Apple Watch. Okay, so as a summary, the web evolves frequently. Okay, we know that. So we should stay on top of new capabilities because this is changing all the time, right? Yeah, one way is to come to CTJS every year, okay? But try to stay on top of new features and APIs. And please use progressive enhancement because, not every feature will work the same on every browser, on every platform, okay? Make sense? So after saying that, I have an overview. And if you want to learn more, you can check web.dev learn PWA. It's free. Okay, you have more examples and interesting links to see. Okay, so thank you.